Morning. How's everybody doing? Thank you for showing up. It's a lot bigger turnout than I expected, so thanks. Woo! We haven't seen the agenda. I'm John Rodriguez. I've been in offensive security space for about 15 years now. DoD side, private side, consulting, research and development, EDR companies. And now I'm head of CyberDaggers, specifically on the capability augmentation side for our clients. So we're going to be discussing forging the adversary. Come right in. Yeah. So one thing with the when it comes to adversary simulation, red teaming, pen testing, I know we tend to use them interchangeably, but realistically there's different methodologies, even psychological aspects, especially when you're building a team from the ground up. And so we're going to look at rethinking that mindset. We'll kind of break the mold and then move into a discussion about malware versus software, and then an operator-centric customization framework for you to be able to actually carry those adversary simulations. Essentially, we're going to talk about hacking and doing cool, amazing things, all right? Have you ever been on a red team exercise? It may look something like this in terms of we're going to get that C2 out there. Oh, it got caught. We got domain admin, and we're proving 100% MITRE coverage when the reality is that adversaries will stay within the network for over 180 days, 9 months, couple of years, depending on their dwell time, TTPs, and what they're going after. So we're not actually testing the security stack, just kind of validating some of that marketing that we see from vendors. Again, used to work at an EDR company, so a couple of jobs here, but one thing that I tell my clients is just because you detect something in a static environment, such as an evaluation, does not actually represent the value of that solution. At the end of the day, our environments, whether it's enterprise, SCADA, even small businesses, they're dynamic. Users are going in and out. There's traffic from different sources. So you can't actually pinpoint and say, this security is going to be better than this. You have to tune those security measures for your specific business need. One thing, especially on the executive suite, at the end of the day, the reality that you encounter is that if you're in a red team or even emulation team, depends on your capability of that team, the maturity of that team, you may not actually have what I would say the necessary capability to go after maybe APT28 or Turla and kind of dig down into those specific components that makes them such a adversary. You guys coming in? Good. Come on. Yep. Yeah, go ahead. One thing that I especially would like to emphasize is strategic objectives and any threat-based assessment. We're not going necessarily domain admin. That may not be the objective at all. Tends to be kind of noisy. Sometimes what I want to do is see if I can get into your maybe development network, finance network. Depends on the maturity of the client, of course. So for operations to be successful, especially cyber, it's not just in a silo. It's not just magic happens, right? There's a fusion of intelligence that comes in from all sources. Human intelligence, human signals intelligence, SIGINT, and open source intelligence gathering among some of the efforts. Now, on the commercial side, hit or miss, depends. A lot of this stuff does come from the government side, especially when it comes to operations. But one thing that I've told the red teamers is work with CTI, your intelligence divisions. Have them feed you those cyber threat intelligence reports, and you can make those educated operational objectives moving forward, rather than just, thank you, rather than just sitting there and throwing a bunch of TTPs across and seeing what sticks. Well, a lot of us maybe come from these backgrounds, but for the most part, may not have the capability to do it in-house. So fusing these capabilities comes in key areas. Now, human can be simple social engineering. You could be calling up, just walking into the building, seeing how they are, what's their pattern of life, who's showing up, what schedule they work. Same thing with signals intelligence. Doesn't necessarily mean you're over here, cracking SS7 or anything like that. You just want to see what signals are coming out of that location. Is it a Wi-Fi? Is it cellular? Is it SATCOM? And open source intelligence, same thing. What's out there? Are they disgruntled employees? Is there any sort of financial gains or secrets that are out there being exposed? So for your human intelligence, I was describing the pattern live and crafting those lures, understanding that at the end of the day, we're all humans. We have bad days, we have good days. We're not always happy at work. We're vulnerable, especially with insider threats, whether it's finance, whether it's marital, there's always, some sort of factor playing within our organizations. Signals intelligence, especially now, kind of the golden age of more commercially available drones, where you can easily build, for example, small UAVs, small drones at home, stick a couple of flight computers in there, a couple of equipment. $600 later, you have targeting capabilities, facial recognition, signals intelligence in an easily discardable package. Someone's at the door, deciding if they're going to come in or not. Nope, okay. Now, I highlight the targeting engine, and that's typically whether it's your stakeholders, when we prepare a targeting package, this goes into everything that we're fitting into our operation. So what are we going to do? What's vulnerable? What's out there? Some things may be significant, some other things may not. So adversaries use the same principles across the spectrum, whether they're targeting a mom and pop shop, whether they're going after Fortune 100 companies, oil and gas. One thing that common denominator across these adversaries, especially if you start looking at Cozy Bears, GRUs, units, is a lot of custom in-house capability. They have a synergy between the operators and the developers, at least for the most part. Everybody does have their A team and all the way down to their Z team, right? But for the most part, everything is built in-house, grown, and unless they're doing false flag operations, you may not see too many commercial command and control or techniques being utilized. So for malware, right, we have our sandboxes, we have our EDRs, XDRs, whatever marketing lingo's out there. But at the end of the day, does your team internally for your adversary emulations, do they treat it as a software product? Are you using best practices, DevSecOps, right? Malware doesn't necessarily have to mean that it's going to beacon out every single time and you have command execution. And we'll get more into that, but you build your capability to that specific objective. So what's the issue with off-the-shelf tooling? There is signature, but for me, they're great. I've played with all of them, have all of them. They have their purpose, right? Not everyone's going to sit down and spend the next 5 years developing one single command and control system for one single client, right? Unless they want to fork out the money, why not, We'll do it. But they have a design for a broader audience, right? Your C2s, whether they're extendable or not, they may, have some capability to be on Linux systems or Mac systems, SCADA, kind of differs depending on the product. And again, signatures, behavioral, static. And at the end of the day, if you didn't build it, how well do you know how it operates, right? Sometimes things happen. Typical example I like to use is if you have an SSH session with Metasploit and you do session TACU to upgrade it to an interpreter shell, what does it do underneath the hood, right? Is it actually magically putting that SSH session into an interpreter, or is it actually uploading an executable into the system, running that service executable, doing the DLL, reflective DLL, and then spawning that interpreter shell for you, which will get caught, by the way. Don't do that. So when we're looking at tradecraft, we're looking at our capabilities. Things that I like to, at least for the red teams that I've built, is applying the 5Ds, right? What are the 5Ds? So 5Ds are Air Force doctrine for cyber operations, DoD doctrine. It's public knowledge out there, non-class. And you'll have your deceive, degrade, deny, disrupt, and destroy. And within these kind of fall different subcategories, what capabilities you're going after, and especially in the client side when it's commercial, they still get ransomware, they still get wipers, right? They still have destructive actions conducted against them. Whether it's an insider threat, wiping a database because he got fired and somebody forgot to turn off access to him, or they're degrading, especially right now what we see with large language models, you're degrading their fidelity, poisoning their training data. So I like to center any capability development around these. What are we going to do first? What's the first objective? That should guide you through your development process. So rather than undertaking this huge project, you want to emulate X, Y, and Z adversary. What do we do? Let's just start coding everything. We'll rip GitHub apart, throw it in whatever GPT there is, and hopefully come out with something that does what's intended. You break it into smaller pieces. You have your continuous integration, continuous development pipelines, and you build it with security in mind from the get-go. John, why? It's just command and control. It's going to get blown up later on. Well, whatever you have, your command and control is used to simulate exfiltration of data, sensitive data. Or for the most part, you want non-attribution, even when you're dealing with your clients. The good guys, whatever EDR company out there, at the end of the day, they're doing their job. We have to do our job to best replicate the adversary. So one thing, especially on this one, when you're looking at the development side, and you may think, hey, why do you need to comprehend these? This may be out of place, but when you look at these, then these are APIs specifically for the Windows operating system. You start developing a capability, you start using whatever language you want to use. It really doesn't matter. But these are all normal APIs within Windows that if you look at System Indexer, for example, you'll find all these APIs. What's System Indexer? When you type whatever document on your search bar, that's what gets called to look throughout your operating system and find whatever document you're looking at. Now, these APIs, there's a threat pool, create a threat pool timer, wait for single object. They're all found in malware too. Right? Now, does it make them inherently bad? No. Now, if there's just one program and the only APIs that calls is these, and the only thing that you'll see it on the heuristic side is performing malicious activity, well, that may be a dead indicator. Now, let's say you build out the program and it performs other actions, it has a bunch of junk code and garbage code, then the amount of actual malicious activity shrinks. Kind of with the way I describe it is within the whole fog of the program. Now your slice of actual, threat pool APIs may be 4 or 5, and there's 100 other APIs that are being called within the program itself. So when you start planning, again, those 5Ds, let's say we're going to go after we want to get intelligence. We want to make sure that we have a stage 0 that's going to live long-term in a Fortune 100 company. We know that they have good security. They should, based on, on their requirements. And then we'll build off of that. So this is where you start thinking more on the development and operator side. So your operators, especially if you are 2 shops, one for research and development and one for operating, you have that synergy between both shops, and you're just not developing anything crazy. And then your operator's like, I don't know how to use this. I don't know how it works. You're creating IOCs yourself. So it's good to kind of sit down together. We'll have planning meetings, attack planning meetings, and they may last an hour, 2, 3, whatever the case is. but at the end of the day, both sides of the house come out with a good understanding of that capability in the tool, and especially development understands what they're required to produce for the operator. Sorry. They're good. Secure by design. Just like any piece of software out there that you're putting in an enterprise environment, it should be secure by design. One, yes, it is going to be monitored, and be inspired. You saw all the C2s, everything out there, whether open source, closed source, whatever the case is. Be inspired by it. Don't just copy it and rip it. Again, signatures, heuristics, classic fork and run scenario. How many actual Windows applications or any OS typically will do a fork and run for legitimate purposes? Not too many, especially nowadays where that is a common trend within C2s. There was a time for it, but now you have to evolve, especially with the security measures in place. Modular architecture. When you load, let's say, a client, agent, whatever you want to call it, and it's 150 megs. Is it modular? Maybe, maybe not. Now, if you don't have modularity built into your client and it gets burned, well, everything's burned now. Maybe your TTPs for proxying network traffic, for if you were doing indirect syscalls, maybe you have a novel technique for process injection. Now it's completely burned and ruined, and the defenders, for example, in this case, will understand your capabilities, easily signature, and trust me when I say that the defenders talk and they understand what that piece of malware is doing, especially if it's being reverse engineered, and then getting attribution to it. Segmented infrastructure. Are you going to connect directly back to your command and control system? Hopefully not. Same thing, if you're looking at other clients, proxying, corporate environments, never want to really connect back directly to the home net, especially you don't know what kind of traffic it's doing. If someone actually took over your agent, is replaying your packets. If you ever upload anything into Falcon, Sentinel-1, and you'll see their sandbox going over and over and over again, and you'll see the traffic hitting back your redirectors or your infrastructure with these, funny usernames. Now imagine there's an adversary doing that and it's able to infiltrate you instead. Now, as a security company, you don't want to be in the news, especially for being compromised. And the security controls. For security controls, you see a lot of individuals out there with C2s, hey, just plug it in, connect the client, connect the C2, start putting out payloads, but there's no authentication, there's no auditing, and these are crucial, especially for clients that may be in the government space or, high fidelity clients where you want to show them everything that happened for the operation. You want to replay packets, you want to show them what was built, why was it built, and you also want to be able to share with them that that is not being released out into the wild or used to compromise, other sources that shouldn't be. So for modularity, now I got kids, so Legos are the vein of my existence, right? You step on a Lego, but there's the best way that I looked at it myself. Instead of having your monoslab or monolithic programs, segment everything out that you want to do. You have your core, you have your center, your agent, maybe that's your beacon loop. But everything else, enumeration, networking, user, any actions are all plug and play to the actual implant itself. That involves the code obfuscation, and depends on what security product you're going against, but one of them really doesn't like entropy, right? High entropy, bad juju. Says, hey, this is malicious. No one's encrypting with AES 256 GCM your regular user programs, right? True, to some degree. Same thing with execution flow of that agent. Is it going down and automatically executing all the APIs, or are there no APIs in the import address table or the export address table? That's pretty suspicious when it comes to actually developing clients that blend in with the environment. And then the isolated systems. Do you test in production? No. Pretty simple. Same thing with software development, implant development, offensive capability. You want to replicate the client's environment to the best of your ability. Absolutely, whether that is through third parties for the most part, and understanding those policies for those EDR vendors, security stack, email gateways. But at the end of the day, you don't want to just deploy something pretty much in prod and have fire at it. It does not end well. And there's legal implications. Not a lawyer, so I'm not going to get into that. So that modularity when it comes to the development side. This is more of the visual concept for it. Now, how do you modularize different capabilities? Could be a hot plugin, so something that you send your command and control server and says, hey, load this DLL reflectively in memory, put the code, once it executes it, deletes it. Now you zero out the memory securely, 3 to 7 passes, and then you discard that DLL. Now, we tend to avoid writing to disk as much as possible. There's ways to do it just on memory itself. Sometimes you do want to drop, let's call it a nugget on memory, on disk that's encrypted, and then that gets loaded. And that'll help you with your stack frames and making sure when you're executing, any sort of capability is backed by disk. That way your EDR is not looking at it as, hey, this is not backed by anything on disk. Why are these memory regions, performing these type of actions? So for us, typically it's recon, persistence, and network reconnaissance that also get modularized. Testing. All right, I don't know how about you, but I guess, first coming into the industry, you want to do all the amazing, super awesome things, and you hope it works. But then you write 1,000 lines of code later, and you don't understand where the bug is happening, why it's not acting the intended way. Is it working on this Windows, especially Windows, right? You got Windows 10, 11, fall patch, summer patch, spring, different versions and subversions. And typically what changes a lot with these versions is your syscall tables, API definitions, kernel, NTDLL, different aspects within the Windows operating system itself. So maybe something that works on Windows 10 no longer works on Windows 11, especially when it comes to kernel security, page guard, all these extra security measures that Microsoft is now implementing. Especially now moving on to Rust implementations in the kernel, things are definitely getting a little bit more wacky and building a bigger abstract layer. Not sure if you guys saw, but right now, Microsoft is working with the EDR vendors to move them out of the kernel and back into user space. Famously because someone crashed half the world being in kernel space. I don't know, but it happens, right? I was trying to fly when that happened. That was not fun. But so when it comes to testing, especially the validating controls, what I like to do is I have 2-person integrity with the team. If I build it or someone else builds it, they verify that it works as intended. They understand what I was trying to do. Obviously, this is not extremely documented, but for the case of explanation here, you'll have your get module handle and get process handle, and same thing with your debug output. Now, in terms of this, which is a dynamic load library DLL, and you're abstracting the C runtime, you can't debug it necessarily just with MSVC and run debug. You have to build your own debug logic into it, and that's fine. Again, debugging purposes. Obviously, that gets stripped out at the end via CMake. But then I send this off to the peer, and they're like, hey, this is okay, or we could do this better, or maybe your pointers, you're not casting things correctly. It just kind of depends, or it's not actually doing compile time hashing, right? And then verify parameters, because you do not want double freeze, memory leaks, buffer overflows within your own, especially when you're talking about offensive capabilities where they can be exploited. So efficacy testing. Now, my last three organizations loved the term efficacy, right? It's like, oh, we're going to do efficacy testing. All right, well, what does that mean? Well, we have $10 million and we want to buy this product that says they're going to protect us against every known threat out there. But then we have product A, B, and C also claiming, the same thing. So from an offensive capability standpoint, a threat actor pretty much has to follow the same concept. Now, they may not necessarily be forking out the money themselves, but there are ways to get those systems, and yes, you're vetted for the most part. But at the end of the day, there are programs out there that you can collaborate with the security, industry to validate their needs. Sometimes it works out, sometimes it doesn't, but we'll break down a little bit of what goes into the actual TTPs and how you can at least understand some of the basics when it comes to these EDR vendors. Signed files. All right, so now if you recognize this dashboard, that's great. No, we're not naming anybody here, not trying to make any more, pissed off engineers. But at the end of the day, so we see that Explorer EXE is the parent process and originated from Explorer. Now, Explorer typically should always be a signed Microsoft executable, right? So that's great, no issues there. But something within the documents and the release directory based on behavioral AI, now however this vendor classifies what behavioral AI is, determined that it was a hack tool. And the detection type was dynamic, so it probably ran it on the box, quick ML, and said, hey, one, this is not signed, there's no publisher name, there's no signature identity, it can't validate that signature. This could be suspicious at the end of the day. Most legitimate software companies, if not all, should and will have validated and verified signatures, signature templates. And for example, when I was talking about different versions, you'll see the OS version and the agent version. Now, when it comes to signatures, when it comes to behavioral, all the analytics, a lot of it depends on that agent version. Some agent versions are able to detect X, Y, and Z TTP, and some of them are not. Typically, especially if you're upgrading from a major version to the other, you'll do incremental updates, and then you'll actually test your payload against those incremental updates, see if it's being detected. Hashes. Now, hashes is what I consider very, I don't want to say old because I don't want to insult anybody, but it's not as effective, right, as you're testing heuristics, behavioral analysis. The thing with cryptographic hashes, when it comes to, for example, this Pegasus binary, and you'll see here the dashboard, it'll have SHA-256 hash to it. Well, that's great. What if I just add a period to that source code and I compile it again? Or I compile it with a different time, different compiler. This whole hash thing changes, right? So it's not a reliable way. Now, it's great to have static repos of this. Things get leaked on whatever leaked, forum. You'll create static signatures. Fantastic. That is part of it. But especially nowadays, runtime compile and other methods, especially obfuscation, static alone isn't going to get you through. And one of the vendors that you'll see here later on primarily does static detections. And like, hey, at the end of the day, if you're saying you're protecting X, Y, and Z entity, are you actually being as effective as you're claiming to be? Comms, probably the least favorite to favorite part of any development is communications. Why? Well, because everything happens with your communication stack. Now this, I label it the worst implant ever developed. And what you see here is, one, there's no HTTPS or even any sort of encryption when it comes to the communications itself. you'll see that everything is static user agents, leak full process. There's no session binding. There's no integrity, authentication, or replay protection when it comes to the actual communication module. So how do we address this? Well, encryption, compression, and key exchange are your friends. Now, entropy plays a lot when it comes to your encryption, but again, this is on the communication side, on the network side, and everything gets wrapped up anyways in TLS. So typically, whether you want to do encryption, you should do encryption beforehand, whether it's AES or ChaCha, and then you'll do compression of that encrypted data. And then sometimes you'll just add base64 to it again. That way it looks pretty normal with internet traffic. If someone's being able to strip down layers for TLS, then you'll put it on TLS 1.3, 1.2 still, for compatibility purposes. And then your key exchange, vital. On your key exchange happens once that implant calls back, it gets validated with the server, and the server validates the implant. Now, if that doesn't happen, let's say I can signature your implant, replay the packets, right? You'll throw SCAPI in there, SCAPI, and then start looking at network logs, replay, and now the server accepts any communications that matches that signature. Well, thank you. Now I just compromise your infrastructure. So when the key exchange happens, what you want to have to do is that key exchange happens once per session. You have a time skew, right? Because things take a little bit over time. And then you'll actually accept the communications on the end. I do apologize for the blurriness on this one, but once you move out of comms, you're looking at the actual functions of your agent itself. Some things that, again, this is more for C, C++. If you start looking at Rust and Go, typically you don't worry about this part. But the C runtime for Windows, it's great. It allows you to have abstract classes and you do everything that you want to do, whether it's a read file, open an internet socket, a web socket, whatever the case is. And Windows does a lot of the heavy lifting for you. You don't have to worry about calling intrinsic functions or anything like that. The C runtime takes care of a lot of that heavy lifting. Now, the C runtime also allows the defenders to quite easily signature what APIs you're calling, what's your intended purpose, and then trace that back into kernel land, kernel callbacks, you name it. Well, if you remove the C runtime, you have to do everything that Windows will be doing for you. So if it's string copy, simply copying a string, you have to implement this manually. Now this is where you start playing with memory and buffers, and you make sure that you're allocating memory, deallocating memory, and variables. So you have to have a whole chain of understanding when it comes to the memory of the implant. But at the end of the day, your overhead shrinks dramatically, and then you can put whatever APIs you want to show on the agent itself. So instead of having an agent that, create remote thread or anything like that, you can show it and it may look like it's just a GUI application rather than maybe a loader. So when it comes to string IOCs, this is kind of the same concept when it comes to the CRT, the C runtime, comms, same thing with strings. A lot of the validation that we do, whether it was that AES or key exchange, URLs, IPs, URIs that are baked into the implant itself, so it knows what to call, who to call, what processes to utilize. Typically, what I consider them is pretty sensitive, right? You don't want to just have, example, super sauce, your URLs and all that. Now that'll show on comms, but for static analysis, maybe you just want to show a bunch of garbage code. Now this one, you'll see that it actually goes and has this plain text string here. And then when you go run it through typical strings, it doesn't show. Now that's due to compile time hashing, which then, granted, if I run through an EXE or a DLL and there's no strings, that's an IOC itself. So there's a careful balance between too much obfuscation and blending in with the environment. A lot of novice, capability engineers want to throw the whole book at it. Next thing you know, that is the IOC itself. So when we're doing the deployment side, let's say you've implemented your string obfuscation, your encryption, your comms, you have everything that you need, the implant's working perfectly, it's not getting picked up, you test it against everything out there, fantastic, that's great, all right? Well now, how do you secure that capability? How do you ethically and legally ensure that you, as the engineer of actually being able to create such a capability and helping the client, hold yourself accountable at the end of the day? So typically what I like to recommend, and now this may work for your organization or not, but every single payload is always linked to that specific operation. So if you're doing efficacy testing against oil and gas, those are built specifically for that client. And obviously your operator, your teammate, that's tied to them as well. There's different tech stacks to do that. Typically, just make sure that one, the property file on whatever compiler they're using is tied to them. They have a specific UID, and the payloads have the UID as well, along with if you assign a customer UID, a unique identifier for the payload. Now this is how, especially now, one of the bigger C2s out there, I believe a year and a half ago, they helped take down 1 million something IP addresses worldwide. And they track every license ID to every customer. It goes in every single packet that it sends out, and they know exactly where that's being deployed at. Because before that, it was just being used rampant by threat actors everywhere. So again, the no reuse by clients, I know it probably seems like a lot of overhead. Didn't say you couldn't have templates and build from that, but when you do compile for that specific client and you tailor it for that operation or that client, it is beneficial just to have it custom made for them. Signed and version artifacts. All right, so getting certs, valid certs, poses a challenge, especially because the GoDaddy or whoever it may be is going to validate you as an individual and as a company. All right. Now, if you're an offensive capability company, probably not going to pass that background check. Ask me how I know that. So, at the end of the day, either you self-sign certs, you find certs, or there's third parties that will sign the certs for you. And then another thing for the payloads themselves is that they're stored. Now, a lot of people just put it on GitHub or GitTia, internal, repos, and that is fine to a degree, but then have that audit and login there as well. I can't stress enough where, especially if you have 1099s coming in, your contractor, whatever the case is, and to just go in there, start ripping down payloads. Next thing you know, your payload's showing up on VirusTotal on an oil and gas client where you're supposed to be on a banking client, right? That's pretty suspicious. And if you want to destroy it after use, typically what we do is we signature all of it, we put it in the sandbox, we get the IOCs, and we burn it ourselves, give it to the client, and say, hey, if you ever see this on your network again, it wasn't us. Here's all the IOCs, all the COM. We just don't give them the source code. Same thing with defenders, particular certain EDR vendors. They'll try to strong arm the client. We want to see it. Be like, nope, sorry, it's gone, for the most part. So on Hack SpaceCon, got a lot of talk about the Artemis thing that we were doing. Now, not sure how many of you were in the panel. I'm a firm believer in reality of AI capabilities and LLMs, right? It's not Skynet. We're all still walking around. There's no Terminators going after us yet. So that's great. But it is here to stay, and it's here for what, different purposes. Now, ethically, legally, that's, different wheelhouse. But at the end of the day, for example, our corpus of raw source code, whether it's C, Rust, C#, whatever the case is, and you're able to actually run, now that you can run your LLMs locally, let's say you have, I don't know, a couple, 50 90s, 8, 9 of them, you can run a couple of agents on them, and then have that RAG pipeline, retrieval augmented guided pipeline, you're able to actually analyze your beacons. And one thing that I like to do is say, hey, you built the best beacon in the world, right? You're absolutely killing it. Well, sometimes it happens. I'll have one of our engineers, he'll be on leave or whatever the case is. And I'm like, hey, well, I want to understand what this beacon is doing, what's going on, what IOCs do we see, from the get-go. So right here, you'll see that based on the source code, now this is part of the auditing process, but based on the source code that it was used to create the, on the source code that was used for the implant, it's using direct API calls, it's using predictable C2 beaconing, plain text strings, and the different agents will start, kind of giving you the IOCs, and you'll be able to do the code comparison and remediation code as well. So there's another look of it. Again, this is just in-house, but pretty much it helps us understand what we need to tailor and any recommendations on the spot. So it just shrinks down the operator's time to have to talk to development, or if they're doing development themselves, hey, where did I go wrong? What can I do better? At the end of the day, I want to save them time and not have them work on a single capability for 7 hours each day, and they're getting stuck, right? So it's all about helping them be more efficient. So we see here, after we kind of go through all our capability development, this one was specifically to dump LSAS. We see that it was against a specific vendor. It is connected to the cloud. So again, love to tell the teams, just because you don't have it connected to the cloud doesn't mean, and it didn't get an alert, doesn't mean it actually bypassed anything. Especially the vendors now, they search across all their tenants, all their clients for all the telemetry and correlation data. So no cheating, has to be connected to the cloud to actually be bypassed. So this is able to dump credentials without being detected. Do better next time, right? Same thing with these with this other vendor here. This one is more of a same thing, LSAS and living on disk for a couple of weeks. No threat detections, not necessarily their fault. And as you can see here, that they do have all their protections enabled. Questions, comments, concerns? That's it. Woo! And time to spare. Okay, question?
So I was thinking, earlier in the talk you were kind of going on about how, you need to make sure your C2 is secure, you're using proper encryption and making sure it's not vulnerable. And I saw recently on the news, probably a week or two ago, about Danabot was just leaking its memory in responses, and that allowed a security company to kind of identify who was running Danabot. So what kind of is your experience with sloppy C2 development, and how do you think offensive people can, make sure they're not accidentally introducing more vulnerabilities into their clients' networks?
That's a great question. And from a developer standpoint, right, at the end of the day, we're not perfect. We can make mistakes, right? And it happens, especially Cobalt Strike, for example. Love4j, they've had a couple of CVEs on their, platform before. It happens. It's a giant project, whether it's the server, the client, or the C2. But at the end of the day, it goes back to that secure by design. And yeah, sometimes it's not cost effective to go back and rebuild something from the ground up, especially depending on the framework and the language it's written in. So you have to do your best for static analysis and dynamic analysis. But at the end of the day, I think it comes down to, do you have the best intentions, especially on offensive capability, to release a product that you can say, hey, I stand by it. If there is a mistake, it gets patched, and then be able to learn from that experience. Now, if you're constantly releasing, software that is buggy, that has issues, whether it's and it goes back with not just C2, but VPNs or firewalls, same thing like that. You have to make sure that you're doing the due diligence.
So,
yes, sir.
John, in my experience, you're going really deep.
Mm-hmm.
And I've seen penetration tests ran thousands of times. You never need anything like this, unless it's like a military grade installment.
All right.
Unless I'm wrong, I don't know if that's what you've seen.
You're correct. A lot of the times, and you'll see it, you'll do the same company 3-4 years in a row, same vulnerabilities,
Yeah,
right?
I was going to say I asked for 3 pen tests.
Yep.
And I want to understand what systematic process problem they have.
Yeah.
And I'm just wondering, what do you guys do when you're writing reports? Do you ask for pen tests that they've had previously, just so you can go back and say, hey, make sure that you've already taken care of what you've been told was a problem?
So when it comes to, for example, on the red team side, right, that this is more applicable to. My biggest thing with a client is, you want to come to us for a red team, adversarial, whatever the case is asking that question. Hey, have you done pen tests before? Have you done a purple team before? I always preach, do a purple team first. That way you can actually tailor down your perimeter, tailor your detections before you say, hey, I want a 6-9 month red team stealth. It's going to cost you, X, Y, and Z. And then at the end of the day, what we want to avoid is being in that stakeholder meeting, especially the exec suite, and it looks like they got egg on their face, right? Because that's not what we're there for at the end of the day. We're there to help them get better at security and help their defenders. But if they're, and a lot of companies don't do it, I get it. They want to make that the buck, and we all have families to feed at the end of the day. But I think it's a simple question to say, hey, have you had pen tests before? Have you? What's your remediation like?
Does I'm just throwing this out there.
No.
Do you guys do like a purple team exercise with the company? You can call it a pen test.
Yeah.
But say, hey, we just broke into you, and this is what we did. This is what you need to defend against during the test. And then have to up your game to get past what you just told them they need to correct.
So normally we'll do purple to red instead of red to purple. So yeah, so we'll go sit there. Now, obviously we have our own, how do I put it? There's things that we develop for purple, things that we have for like our stealth assessments and things, inside stuff. But at the end of the day, if you're not making my job harder, then I'm actually doing my job and I'm helping the client to the best of their ability. So at the end of the day, that I call it ego teaming. A lot of red teams, organizations like, oh, we did this, we did that. And then they just walk away and the client's like, well, now what, So we like to stick with them throughout that whole process. And if things get burned, so be it. We got to do better. So awesome. I know it's hot in here, so and I think it's coming up on the 15 minutes already. But yeah, I'll be around. Slides will be up, and I believe did they record this? Yeah. Yep, they recorded this, and then the slides will be up as well at the end tomorrow night when I get back. So appreciate it. Thank you.